In this video, we're going to talk about properties of limits. I will start with this example first, then we're going to talk about the properties. What is the meaning of limit as x approaches to of x squared? Now, whenever you're given this to evaluate any limit, the first thing you will do is to try to replace x by the value we have. So since x is approaching 2, directly I go to the function, replace 2, and try to get an answer. If I get an answer, so in this case we say limit as x approaches 2 of x squared is equal to 4. Now later on you're gonna see some cases where when you substitute the value, which is 2 maybe, or different value, we don't get a specific answer. So either we get 0 over 0 or maybe something over 0, which is undefined. In that case, we need to do something else. So let's learn this step by step. So I'm gonna start by saying suppose limit as x approaches a of the function f of x equals to L, and limit as x approaches b of a function g of x is equal to n. The first property is limit as x approaches a of the sum of f of x plus g of x is equal to taking the limit as x approaches a for f plus take the limit as x approaches a for g. It's wrong to say distribute the limit. Just we're gonna separate this expression and write limit as x approaches a of f of x plus limit as x approaches a of g of x, which is, if I take the first one from what I wrote before, it's equal to L, plus what I wrote before, this is equal to n, so it's L plus n. Now, does this work if we have minus? Yes. So if you have minus, minus is same as addition, so subtraction is same as addition. Instead of writing plus, we can write minus. Let's look at an example here. If I tell you limit as x approaches 2 of x squared plus 3x, or plus x now, just I'll write x. If you want to do it in one step, you're gonna tell me it's 2 squared plus 2, which is 4 plus 2, and it's equal to 6. Correct. This is correct. Now, does this rule apply? Let's check. Or, because we have addition, so I consider the first one to be f of x, this one g of x. So we can take it as limit as x approaches 2 of x squared alone plus limit as x approaches 2 of x alone. And to evaluate the first one, we're going to substitute 2 instead of x. To evaluate this one, we're going to only substitute 2 instead of the x. And in this case, we get 4 plus 2, which is also 6. So you can solve it both ways. Just I was showing you that you are allowed to separate the limits. Take the limit of the first part alone, the limit of the second part alone, and then add at the end. So this is one of the properties of limits. 2. If we have product, limit as x approaches a of function f multiplied by function g. So also if we have product, we are allowed to separate, so I can write limit as x approaches a of f alone multiplied by limit as x approaches a of g alone. So the first one we said it's L, I write L, multiplied by the second one I said n, so multiplied by n. Now, as an example, if I tell you limit as x approaches 2 of maybe x squared multiplied by x minus 1. If I'm solving this directly, you can substitute, so 2 squared multiplied by 2 minus 1 it will be 4 times 1, which is 4. Now, can I apply that rule? Let's check. Limit as x approaches 2. I'm gonna take x squared alone, then I will multiply it by the limit as x approaches 2 of x minus 1. So I get for the first one 2 squared, and for the second one 2 minus 1. So I will get 4 multiplied by 1, which is 4. So in both cases, you will get it correct. 3. Now, if we have limit as x approaches a of a constant number k multiplied by a function f of x, the k is a constant number, no need for it, so we can take it out. It becomes k multiplied by limit as x approaches a of f of x. So if I'm using this one to be L, in this case I say it's k times L. I'll do an example about it, and then we move to a different property. So let's say I'm telling you limit as x approaches 2 of 3x. When you're solving this, you're gonna substitute x by 2, you get 3 times 2, which is 6. Great. Can I apply the property? Let's check. So limit as x approaches 2 of 3x, the 3 I don't need it, take it out. So is this equal to 3 times limit as x approaches 2 of x? Let's check. So 3 multiplied by. Now here we're gonna replace x by 2, we get 3 times 2, and it's exactly the same answer, which is 6. Property number 4. Limit as x approaches a. Now I'm gonna talk about a quotient or fraction. If we have f of x over g of x, and here we need to know that the denominator cannot be 0. Okay? Can I take the limit of the numerator alone over the denominator alone? Yes, you can do that. So it's exactly the same thing as limit as x approaches a of f over limit as x approaches a of g of x. We said it's L over n in this case, knowing that n cannot be 0. So the limit as x approaches a of g of x is not equal to 0 because it's in the denominator. Example, if I tell you find the limit as x approaches 2 of 2x plus 1 over x plus 3. When you're doing this, you're going to replace x by 2. And you get 4 plus 1 on top, which is 5, down 5, and the answer will be 1. Correct. Now, just as a reminder, whenever you substitute the x by its value, you don't write the limit. As long as you're simplifying, the limit should be written. So as long as there is x written, we should write limit. Once we substitute, no need to write the limit, okay? Can I apply the rule which is separating? Let's see. Limit as x approaches 2 of the numerator alone over limit as x approaches 2 of the denominator alone. So 2 times 2 plus 1, this is for the first, the numerator, over, down the limit of x plus 3 will be 2 plus 3. And same thing, we get 5 over 5, which is 1, so this property works. We still have one more property. Property number 5. Now, limit as x approaches a of a function f of x raised to the power of n. It's exactly the same thing as taking limit as x approaches a of the function f itself and raise the limit to the power of n. Here we should know that r or n, in this case the exponent, is positive. Okay, now let's check an example about this. Limit as x approaches 2 of x squared. When I'm doing this, I will replace 2 instead of x and we get 4. Great. Can I apply the idea here? So can I write it as limit as x approaches 2 of x alone and take the power 2 out like this? Let's see. Limit as x approaches 2 of x is just 2 and we have exponent 2 outside, so the answer is exactly the same thing, which is 4.